Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to discuss about mean value of uniform random variable, mean square value of a uniform random variable, and variance of a uniform random variable. First of all, what is uniform density function? Capital X is the random variable which is uniform random variable. The probability density function of a uniform random variable is defined as fx of x is equal 1 by b minus a for x is equal to a to b. And this is the definition of uniform probability density function of a random variable capital X. Mean value of a uniform random variable. We know that the nth moment of expectation of the random variable capital X is given by expectation of x power n is equal integral minus infinity to infinity x power n into fx of x dx. So this is the equation of nth moment of expectation of the random variable x. So this expectation of x power n is also denoted as m suffix n. So now here the random variable capital X is the uniform random variable. And what is the uniform probability density function? This is the equation of the uniform probability density function. So now here substitute fx of x is equal to 1 by b minus a for x is equal to a to b. So therefore expectation of x power n is equal fx of x is 1 by b minus a over a to b. So integral a to b x power n into 1 by b minus a dx. So 1 by b minus a is the constant value that is written before integration, and the remaining RHS term is integral a to b x power n dx. So integral x power n dx is x power n plus 1 by n plus 1 over a to b. So now here substitute upper value and lower value of x, we get expectation of x power n is equal 1 by b minus a, substitute upper value of x b power n plus 1 by n plus 1 minus substitute lower value of x a power n plus 1 by n plus 1. So in RHS side take the LCM. The LCM is n plus 1. We get expectation of x power n is equal b power n plus 1 minus a power n plus 1 by n plus 1 into b minus a. So this is the equation of nth moment of expectation of the random variable x. So now here we want to calculate mean value of the random variable. So in this equation, substitute different n values. Substitute n is equal to 1, then we get mean value of the random variable. Substitute n is equal to 2, we get mean square value of the random variable. So that mean value of the random variable, the expectation of x power n is the nth moment of the random variable. So this expectation of x power n is also denoted as m suffix n. Substitute n is equal to 1, we get expectation of x. That expectation of x is also called as the first moment of the random variable. Substitute n is equal to 2, we get expectation of x square. Expectation of x square is also called as the second moment of the random variable. Substitute n is equal to 3, we get third moment of the random variable. Substitute n is equal to 4, we get fourth moment of the random variable, like that. So now here we want to derive mean value of the uniform random variable. So in this equation, substitute small n is equal to 1, we get expectation of x is equal to b square. Expectation of x is equal to b square minus a square by 2 into b minus a. So this is the equation of the, okay. So b square minus a square is written as b minus a into b plus a divided by 2 into b minus a. So numerator and denominator b minus a is cancelled. So we get first moment or mean value of the uniform random variable is a plus b by 2. So this is the final expression of the first moment or mean value of the uniform random variable. Next one is mean square value of a uniform random variable. Since we have already derived nth moment of the random variable, expectation of x power n is equal b power n plus 1 minus a power n plus 1 by n plus 1 into b minus a. See, in this equation, substitute small n is equal to 2, we get mean square value of the random variable. So that is second moment of the random variable. Expectation of x square is equal b cube minus a cube by 3 into b minus a. So the expansion of the b cube minus a cube is b minus a into a square plus b square plus ab divided by denominator term. So numerator and denominator b minus a is cancelled. Therefore, expectation of x square is equal a square plus b square plus ab by 3. So this is the final expression of the mean square value of a uniform random variable. Next one is variance of a uniform random variable. So the mean value of a uniform random variable and mean square value of the uniform random variable already derived. So we know that the variance of a random variable x is given by variance of x is equal expectation of x square minus expectation of x whole square. So this is the standard expression of the variance of the random variable x. So now here expectation of x is already derived and expectation of x square is already derived. And substitute expectation of x square value and expectation of x value into this equation, we get variance of the random variable. So we know that expectation of x is a plus b by 2 and expectation of x square is a square plus b square plus ab by 3, and substitute these two values in the above expression, we get variance of x is equal expectation of x square is a square plus b square plus ab by 3 minus a plus b whole square. So first applying the second term a plus b whole square, a square plus b square plus 2ab by 4. So take the LCM, LCM is 12. So therefore variance of x is equal 4a square plus 4b square plus 4ab minus 3a square minus multiplying minus within the bracket term, we have minus into plus minus 3b square minus 3 into 2ab 6ab divided by 12. So variance of x is equal to a square plus b square minus 2ab by 12. So numerator term is written as a minus b whole square divided by 12. So this is the variance of a uniform random variable. So therefore, this is the concept of mean value, mean square value and variance of a uniform random variable.